Good morning, ladies and gentlemen, and welcome to this session after the coffee break. We have a very rich program ahead of us in this session, which will analyze the concept of disruptive innovation and look in particular at framework conditions for market creating innovation, and also discuss the current competitive position of the European Union with respect to key enabling technologies. In this session we will have 4 speakers, and as hopefully you're now familiar with it, Slido will be in operation. You have the details on the screen at the moment, hashtag REinEU, and we're in room C. So please give your comments through Slido as the speakers make their interventions. So I would like immediately to turn to the presentations by our guest speakers. The first speaker is Dr. Bertrand Fillon, who is the Director General of Research of CTIPC, the French Plastics Institute. He is also head of the scientific committee of the French polymer cluster Plastopolis, and is a scientific advisor of the French polymer group and of the CRIT MDTS in France. He's also involved in the board of NanoFuture, the European platform for nanotechnologies. So Bertrand, the floor is yours.
Thank you. Thank you, Sean, for this introduction. And thanks for this invitation. So my presentation will be to give you an overview of innovation in plastic industry. And you will see that we are able to do innovations at 2 levels, the breakthrough, but also through incrementals. And you will see also the links between these. So in first stage, I will give you a context where we are today in this world, and some example of short, medium, long-term vision, and illustration of the plastic process innovations. So first, IPC, it's a new technical center of plastic industry in France. And you could see we have 4 main locations, 2 in east part, 1 dedicated on plastic, the other one more on composite, and the same way in west part of France, Alençon for the plastic and Laval for the composite. Why east and west? Because if you look at the business industry on the plastic in France, 80% are based in east part of France here and west part of France. Okay, so the goal is to be close to the industry, close to the SMEs to help them. And the small dots are also some small location where we could have a kind of a relay for the disseminations. Okay, so today we are 150, so critical mass, and the goal is mainly to work with industry on a bilateral project, but we are working also on collaborative projects like national or European projects. So today, when we build up a long-term vision, we work with our French cluster, Plastopolis, who are here to help the SME, to help also the large industry to have the vision on the plastic industry. And together, of course, we know the grand challenges. The grand challenges are all the same for all of us. It's aging of populations, it's health, it's energy saving, it's climate change. So all these are the grand challenges. And behind this, you have the market needs. And the market needs are for the mobility, are for the well-being, communications. And if you want to make product, you need to have the manufacturing. And without manufacturing, you do nothing. So the goal is to align all this together. And if you look for the future, when you want to produce multi-materials based on the plastics, for the automotive, people are looking more and more for lightweight. This is why today in automotive business, you are more and more plastic on composite. Okay? If you look for the packaging, consumer goods, it's the same thing. People are looking for intelligent packaging, lightweight packaging. So there is a need, and people push in this way. For the building, the same thing. How to get efficient energy building, how to get smart building. And plastic will be a good material to help this industry. And of course, if we want to produce this, you need to produce this with low energy for the plant and also less scrap, less waste. So that's a key point to make a business for the future. And together with Plastipolis, we build up the roadmap for our French industry like this. And if we go in more details, you could see for the 6 business, transport, packaging, energy, medicals, and so on, you could see some specific target. You know, lightweight for transport, but you have lightweight also for the building, for the packaging. You have specific requirement, active aerodynamism of the car, but you have also active packaging. So all this together, you could see you have a specific requirement, and some case, you have some common requirement. So the goal is to deal with this in a good collaboration and good communications. So example of short, medium-term stakes. If I look the packaging, you could see lightweight packaging is running still the 80s, you know. So yogurt was in 7 grams, and now we have a half, we have divided. Why? Because we work a lot on the material, but also on the process. And this weight will go down in the future, for sure, because materials, we start to add some nano material in the polymer to improve the properties. So we are moving this way, okay? And if you look also in the packaging, for the, you got the can, and now we have this Day2 packaging. So since 15 years. But you have still innovation in the Day2. In the Day2, you have printing, and if you want to create some spark, some intelligence, you have the facility to do it. So when you look this, you could see on a KETs perspective, today we use mainly 3 KETs. It's mainly process, materials, and photonics for the process control. When I look in the medium long term, you could see there is specific needs for the packaging. You have smart material, you have e-packaging, you have very high barrier, control barrier for the packaging applications. So all this together bring us in a long-term vision. And you could see more intelligence in the packaging. So ICT competency will be very important. People are looking more for biomaterials. And so the biotechnologies is also very important for the future. So based on these different requirements, based on the available technologies, we could see in the future how this business could move, you know. Same thing for transport. I will not do for every business, but for transport, you could see on this picture that transport use more and more plastics. In the wheel here, you have more and more intelligence in the plastic. In the inside car, you could see here we develop specific composite for transparency, for the safety, you know, of the people. Intelligence based on the energy in the car, how to integrate energy inside the car to have a self-energy cars, you know. And when you look this, it's the same thing for the aeronautics. So when you look in more details, you need to produce with high throughput composites. You need to produce smart composite and smart plastics. And here, for the car industry, for example, most of the plastic parts are done in different stages. You could start to see with innovation now plastic part in the mold, and you could paint inside the mold directly. There is innovation today on this. And if you think this 5 years ago, people say, no, it never work. No, today we start to do this. And there is a lot of innovation in this business. So now, when I look how this could move in the future, you have the 2 main pillars, the materials, the polymers itself, and the process. The process here, it's an injection machine, but you have extrusion film also, you have every kind of a machine. And how to do this, you need to think on different kind of other machine. You integrate process, laser machining, you have different type of process, and the goal is to help our SMEs to say, hey guys, there is other machine, there is other process, have a look, you could integrate this. And to be able to supply this different business with a lower cost, because that's a key point, you need to push innovation, but the cost must be maximum the same, and lower is better. Lightweight product, intelligent product, integrate function, and think always eco-design. how to produce and have this life cycle analysis on board. And when I look, a lot of products today are more and more on micro part, because you develop sensors, and these sensors are integrated in plastic parts, and you need to develop micro injection molding. And micro injection molding is, I will say, simple things. No, it's not so simple, because when you want to integrate multi-material inside, when you want to have a very advanced molds with less scrap, you need to have a lot of molds with intelligence inside, with sensors, to be able to control everything on time. High precision mold. So that's very difficult today to do this, and there is a lot of innovation in this scope. When you look other business, you know, here it's an example of a MID. So you have two kind of a plastic part connect with some copper wires. The goal is to produce this in one piece plastic part, you know, and everything is done connection in the plastic. It's the MID technologies. Why? Because first you do a lighter weight component, because you integrate everything together. You save space also, so it's very important. And today it's a growing business in some company. In a French company, we have at least two main company producing this. And Radial, it's a big company working for aeronautics. They are doing this. We have REinEU, we have different companies to do this. And we have a startup, if you have been there before this morning, S2P, who helped this company to create this business. And today it's, I will say, incremental, but the goal is to move here on the 3D MID. And 3D MID, if you need to do more high precision, you need to work on 3D part. You need to print this connection in the 3D to be very precise, to protect for the corrosion. So here, it's the next step of the game, and how to integrate this in one step with one machine. Because today, it's the process in different steps, and the goal will be to integrate this in one short step. Sorry. So we have seen the 3D, but think about film. Because more and more, if you look on the packaging, you have labeling. So labeling is very simple. It's a plastic part with colors, and you do in-mold labeling. But the vision is to do this with intelligence. If you look here, long time ago, people are doing plastic film, okay? And people now, they are thinking about to do this phone in a flat film. And now it's to produce such component in a plastic to be flexible, to be used in different 3D product. How do we produce plastic? It's extrusion blow molding, and people are running this. The goal is to run faster and faster, high-speed machine, 400 meters, and to be more precise, to have more and more layers, thinner and thinner. Today, we are able to produce 13 layers, but we start to see some die with thousands of layers. Or you could say, why thousands of layers? Because when you work with such thinner layers, you have a better integrity, better connection between the layers, and you have more efficient film. You could also down gauge the thickness of the film, and that's very important. Always the same thing, less product, less material, lightweight, and so on. So there is a lot of innovation today to produce this. And when I say, oops, move, what happens? Aha, no more battery. Excuse. So the next slide is how this nano-layering system is developing. We start to see some company try to build up such a system. It's a die where you cut the film in two parts and join. It's a very complex die, but the advantage is to move forward in this thinner layer. Here you have a die. It's 5-layer dies. Compared to this one, it's also a die, cylinder dies, and people are developing this die. Why? Because such die, it's 1.5 meters, 2 meters high. With such die, you are smaller. It's a die with this half meters. And what's the interest? The interest is the contact between the polymer and the metal is very short. And you know that polymer and metals, they don't like each other. If you have a long time contact between the polymer and the metal, you start to degrade the polymer. So this is why it's very important to have a die with less contact between the polymer. How I could... Okay. Okay. Okay, so I will continue to speak without a picture, you know, like the old age. You know? So, in fact, in a blown film, it looks like, I will say, a very old technologies, but not, because people are developing more and more the system to cool the film. It's a huge air ring system, and people are doing this with a modelization to have a better efficiencies. And now you start to have a line, not only with air cooling system, but with water cooling system. That means the bubble, have you seen before in the picture, go up, and now you have some bubbles going down. So the extruder are on the top, and the bubble is going down. And the water is cooling the film. Why is interest? Because it's like in the steel business. You are doing a quench. And if you quench your polymer, you have different properties like slow cooling with air. And you could have a better impact properties, you could have a better thermoforming properties. So that's also innovation going in the blown film business, okay? And for those who don't know these technologies, this bubble line is 20, 30 meters high, you know, it's a very big machine. And so this is why it's difficult to control this machine. And people who produce such machine use more and more optical control system to be sure that all the thickness in this 2 meter, 3 meter width film, you have the same thickness. And when you are doing a film thinner and thinner, you know, 10 meters, 20 micron thickness, you need to have the same thickness across this width, okay? And people are doing now 4 micron thickness, you know. So the goal is to move in this multi-nanolayering, and we need to develop also the control of each of thickness. So there is a big challenge in front of us. Okay, good. So you got an extra. So here it's the system of the nanolayering. You could see that's the engine of this. There is different development today. The US people are developing a specific approach. In Germany also, they are doing something here. It's, as we say, the feedstock. And with this such system, we are able to produce thousands of layers. And as I said before, it will improve your properties, optical, barrier, and so on. So another system to texture the surface, it has been developed in CA. It's a pilot line here. You have some nanoparticles, and you have a liquid to transfer these nanoparticles, and after you adapt these particles on specific plates to texture the surface. And you could get nanotexturation, and this could be interesting to calendar on the plastic film or other application for solar energy, for example. And that's another breakthrough approach to texture a film surface. Yes, but excuse, I have a trouble. So here it's the polymer, I will say, next generation, how we could transfer electronics on polymer. And there is different pilot line today in Europe to produce solar cell, to produce some patches. And the goal, as I said before now, is to introduce such film in a mold. And when you look today, injection molding with plastic part is very easy. But when you want to start to do this with intelligent plastic, to get such product, that's the next stage. And the goal will be to produce this. That means not only intelligence during the process of injection, but try to integrate the intelligence in the film, and after integrate this film in a mold to be able to have this kind of a plastic part. That's the next stage to create this intelligent plastic part. So the goal will be to produce all this, and you could see you need competencies on material, process, all automatic system, process control, and also have a vision on a long-term process, okay? So we have the same approach on composite, and you could see the composite. We start to create intelligence in the fiber, in the composite, and I could do the same kind of approach, So, in conclusion, you could see now when you want to produce a product, it's example of PIM, powder injection molding, or 3D printing, you can't work with only one KETs. You're now obliged to integrate different KETs. You need to work in a collaboration. Alone, you never survive, That's very important. And you have always a two driver, the cost and improve. You can't work with a new product with higher cost. Never works this, okay? So you need to think this, and you need to be aligned with the market. You need to be aligned and to be sure you will offer service when you are doing development, and you need to integrate all this software approach, control, manufacturing system interface. So you need to think always when you develop a product to have all this global picture from the beginning until the end, And for the plastic industry in the future, what you could see, it's more and more you use multi-materials, you use different process, and the goal is to produce this intelligent, smart plastic. And that's the vision we have, whatever the process. And that's the vision of the plastic industry in the future. Okay, thank you.
Thank you, Bertrand, for that very enlightening presentation of the breakthrough innovations and KETs implications for the plastic industry, both from the point of view of the materials and the processes, and also for adapting to the technical glitch. So for those who joined us late, let me remind you that we look forward to your questions on Slido, hashtag REinEU, and we're in room C. So without further ado, we move to our next speaker, Mr. Stefan Klein, who will give us a Slovak perspective on the topic. And he is Head of Studio of Transport Design at the Academy of Fine Arts and Design here in Bratislava. Stefan, the floor is yours.
Okay, I would like say that I'm working on Academy of Fine Arts, but parallel, I was co-founder and inventor of flying car, which for me is more important now as position of the university, but it's always dialogue between university and this project. I would like to start with several pillars, and I would like to say that for me was very important this word as garage, because today I spent 25 years in my studio, in my atelier self, and I developed this idea from first idea to a realization of prototype. And for me, it was inspiration from history. And but I would like to say that now this symbol garage was changed, because now garage or atelier, as you want, can work with very sophisticated technology and can open dialogue with other studios and is much sophisticated as, for example, in time of Mr. Ford. For me was very important this dialogue between the local tradition and a global future. For me, a big inspiration and resource was information from our own history, from producer from Czechoslovakia, because I think we had very long history, and I met several chief designers which prepared these excellent prototypes. But what I want to say now is a perfect time that local can communicate it with global and opposite. I have own experiences that we started project with Volkswagen that was very useful dialogue between, and now we have a lot of students, for example, which are working on the perfect studio in Germany or in France. Third pillar is was for me and is now. I think future will have two lines. One is reduction and second is expansion. Because I think we must start these two lines if we want to develop something in our Earth. It's time start with new concept. We must reduce energy, we must reduce weight, and we must change something in our towns and in our country. because we have very limited resources, and it's true. And same project I started with my students with Audi company, was named Micromobility, and we wanted to make some utopia or some concept for future with new kind of energy, with new materials, and with new, for example, situation in the town. Same this project, we took new materials and we want completely change concept of car. Car can be more lighter and must not be as living room on the wheels. And for example, here is a new relation with architecture and with the robotic system that we have chance to change completely our future. Second line is expansion, and in this line I developed my flying car. Is product which can change completely situation in individual transport systems. When I started with idea sustainable or non-sustainable, because I think air is ideal environment for sustainable organization of transport. It's interesting that if we wanted to make some for transport on Earth, we invented wheel, but wheel prepare a lot of problems because need infrastructure, and in air you don't need infrastructure. I started with categorization because when we invented carriage and engine, of course we connected, but today we haven't carriage with engine, we have automobile. Same in motorbike, but in category flying car, it's same situation. It's not very simple connection between car and plane. Due to I made analyze what is plane and what is car, and there came from opposite words completely. Aircraft must be light, car can be heavier, and we can look for a lot of differences. And of course, I wanted to start with some principle. I tested two principles. One is universality, and the second is metamorphosis. I tested universal, that in one object you have several functions, but this concept I changed, and I started with transformation and metamorphosis, and it is some inspiration which I made this animation as example, which kind metamorphosis we can use. And it was something from area of art, but I think art can be very inspirative for engineering. And this dialogue I developed during my developing of this project. Okay, we must go because time is. As designer, I wanted an engineer. I wanted prepare solution for concrete problems. It's traffic jam. We lost status, and this is concept for transport. That our speed between A to B can be much faster as in case if you use jet, because we have procedure, and this procedure you can see on this picture. Our speed, if we use jet, is only 100 kilometers. In case using aeromobile from door to door, your speed is better. It's chance to prepare a new infrastructure, and very sustainable infrastructure, because for landing and takeoff you need grass. And some concurrence from USA, and its connection between car and aircraft. And I think this way is empty. Due to we started new concept, and we used new materials, which what was perfect for us, because now is completely access to carbon technology, and for new technology as example for equipment and avionics, and flying was completely changed, because you don't need so much experience as before, for example, before 20 years. And this example of new avionics with prediction, and you can see that we can use new airways. That is future, but situation was changed in field engines. And in aeromobile, I tested this integration between art, science, design, engineering, emotional, and rational. This is my antipole, which I used. we integrated emotion to engineering. It was for us very important because we wanted to open new emotional relation between customers and I tested on my academy with my students. If you want to create some new form, you have two ways, intuition or calculation and rational way. And I show you very fast our case. We started with project Audi. We started with small drop, with free object, and after we create applicable shape. And it's way only with intuition, and despite is object which is has chance to develop by engineers. And I show you very fast some problematic dialogue between digital and analog. I started always with analog sketches, and after I developed by digital tools. And after we use digital way, and we used completely the very good technology, milling machine. We created new geometry and a lot of aspects of development. Here is some examples this way on. I would like finish with video because I would like show you this final product because you can see this Arcus from idea to realization at 25 years. That is Arcus 25 years. And now is a new version, prototype 4, which we would like realize this year. And probably in February we would like test as new object. These some renderings. And we started with new system for hybridization. It will for next version. We used very advanced technology for CFD analysis, calculation, and here is some structure. And this object, this prototype, we realized a very small team, only 3 people for realization, and other people prepare some financing and some publicity. And during 10 months, we realized completely this prototype with this new technology. Here is structure by carbon. This is final, this is a small team which realized this prototype. And we completely changed this object, for example, interior for the plane. It's combination between car and plane, but it's new geometry. And now I'd like to finish with video, which represented our effort and our final product as prototype, which now need go to professional scena. But there is realized dream that you have in your garage this object, and you can use for transport from door to door direct. That this transformation, we developed new software, special software for this transformation, and we used only these new materials. Due to weight is only 500 kilograms, it's a very light object, and is homologated in experimental category. And a situation that in your garage you can start your plan, your flight plan, and you can fly to range 800 or 1,000 kilometers without problems, with cruising speed approximately 200 kilometers per hour and more. Of course, that depends on quality of engine. And this is situation in town that you can use as normal car. Length is 5.8 meters, and use normal gearbox as the car. In future will be electrical system. And this transformation go very fast. You need only 2 minutes for full mode for the flying. And it is authentic video from first flight. That is, was dangerous, but we are here. But I can say that this flight was very pleasant, and after 2 minutes I was sure that this behavior is as normal plane, was very stable, and cruising speed, as I said, was approximately 200 kilometers per hour. And it's perfect situation today because in frame Schengen countries you can fly without flight plan. It means that if you want to fly, for example, from Slovakia to Germany or from France, that you can fly direct. And it's for me is miracle because I made my pilot license during socialism. That it was more complicated because we could fly only in Slovakia or in Czech Republic. It was for us dangerous fly in other countries. That now is this dream is completely is open, and I think that we can completely change situation in personal individual transport systems because if I compare with plane, which is very expensive, and with using of new materials, and in case that we prepare new legislation, and now we have chance because European Union can prepare this frame for using of new objects because we had good contact with USA team in Terra Fugia. In the USA prepare now special legislation for flying car that I hope that in Europe we will push on this part. And you can see that landing was very stable, and of course I was very happy that I landed. But this first moment was very important for me because as pilot I saw that has potential this object. Of course that this was prototype, and now it's necessary to start with new prototypes, and now we are integrated. We found a company which has several cooperators and suppliers, because for us it's very interesting that in Slovakia, which we had not history in aviation, today we have 5 producers of aircrafts. For our country it's perfect because we have special network, and of course we can cooperate with other teams in England. Now we have very good contacts in Germany and in Czech Republic. That, as I said, now this garage is necessary change to professional company, but I hope that this garage always will be as one part of this company, because garage for me is synonym for new ideas without breaks and without obstacle. Only this dialogue between one own brain to realize is for me is very necessary to keep in company for policy for innovation. And I would like to finish with a picture of my grandfather. And it's pity I didn't met him because he was died. And I have always, before sleeping, dialogue with him, and I have given a lot of questions about future. Thank you very much.
Thank you, Stefan, for that very stimulating case study of the flying car. I think definitely this is an example of breakthrough innovation in action. So now we'll move to the policy level, and we will have now a presentation from Johan Stirna, who is the Senior Policy Officer in DG Research and Innovation at the European Commission. He is working in particular on economic analysis for technological development across the different thematic areas of Horizon 2020. And he's also coordinator of the Secretariat for the RISE high-level group that provides advice to Commissioner Moedas. So, Stefan, Johan, the floor is yours.
Many thanks, many thanks. Well, we have seen with these amazing presentations that key enabling technologies are very important. They're really fantastic. The way I come from, I would put you in a little bit different context. I would make a little bit more overview presentation based on statistical and economic analysis of our role in the EU, in the world, in terms of key enabling technologies. And also a little bit put the reflection from your part on the way in which we organize the support for key enabling technologies, given that they are so important. So I have 3 main issues that why we are interested in KETs. It's almost, but I will try to see it from a statistical perspective as well. what is the role of KETs for industrial competitiveness, and which are the challenges that we stay ahead. And that's, the challenges are more linked to the way we organize our support for KETs and what we can learn from how they do it elsewhere outside of Europe. So the first question, well, as you know, the KETs is a central part of our policy, of industrial policy. And it's also what we are thinking of now is also to link more the digitalization, the digital part, with the other key enabling technologies, given that we are in the middle of a digital revolution. So these are a little bit the background, the policy background, why we are focusing at the EU level. It goes back to 2010, more or less, when we developed a policy on KETs. But if you go even further back, you can see that it's always been very important for the European Commission and the European Union to work on enabling technologies. This is a little bit more complex. This is a statistical analysis. It's made in a project that we have funded, and it's made by Fraunhofer ISI. And it's to show the correlation between KETs, as we meet them, and the big societal challenges areas that we support, which is energy, health, and food, and others. And you can see from both of these are two different methods to see how they are correlated. The one on the left is a method where what you do is to see that when you file a patent in health area, for instance, is that patent also registered in an area that is related to one of the KETs. So there is a correlation somehow. The other correlation is an index where you see across countries, do country invest or are there patents in the country that goes into a health area, and also patents in the same country that goes into, like say, biotechnology. And from both of these, you can see that there is a strong correlation between KETs and the enabling capacity to enable solutions and new products and services in societal challenges, which the industry is moving forward towards. You can see, for instance, that in the left one, among all the patents in the food industry, 13% of them were also registered as patent biotechnology. So you can see that there's a very strong correlation. You can also see on the very bottom that some of these societal challenges that we have in our Horizon 2020 program are very highly correlated to KETs, and others a little bit less. Of course, that depends on the definition of KETs and how we develop that in the future. If you look at the way the larger firms are moving in terms of their innovation, it becomes more and more complex, where you include many different technologies and you try to commercialize solutions. And in this aspect, the key enabling technologies, if they are enabling this, it's very important to really be on the top of that. So what I want to show now is a little bit our competitive position in the EU vis-à-vis the other parts of the world. So if you look here into the where we are, these are the societal challenges, not the KETs, the societal challenges. So you can see that the EU has a competitive advantage, both in terms of patent application and in terms of in which area business invest in R&D, in transport, climate, food, and energy mainly. Also you see in the dark blue line, that's the evolution towards 2020, so in the coming 4 years. But since the area of innovation moves so quickly, it's a time perspective that something can happen also in. But if you look into the areas where we are specialized in terms of KETs, or of all the technology that we are trying to invest in, to which extent do we specialize in KETs? And you see that for the EU, there are very few areas where we are specializing in KETs, which is a very worrying message. you see that in advanced manufacturing technologies, Internet of Things and space, we are specialized. And in view of 2020, it's only space where we will increase our specialization index. So if you want to take this as an overall message, it means that in the future, in the coming 4 years, we may risk losing our competitive edge in some of the products and industries working on societal solutions that are depending on these KETs. So I think for us that is a signal that is worrying, and we try to analyze what it depends upon. So if you look at, this is the position in the world. So you can see what in terms of KETs. So you can see what the US is specializing in, what China is specializing in, and also South Korea, which are the main hubs of technology development today. Of course, there's much more about it than patents, but this is an indication that we have. So if you can see on these slides, you will see that the US and China has a profile of specializing much more than we do in the EU in the KETs. But they are choosing the KETs. And you can see a certain pattern here. So if you look at the US, that's the light blue line, you see a very strong movement in nanotechnology, biotechnology, and to a certain extent the Internet of Things. And also big data. Everything has to do with management of data. In China, you see a very strong movement towards the Internet of the future, and another kind of future development linking to the digital revolution. And we in the EU, we are not having a strong specialization profile in these KETs. So one thing that we could reflect upon is why this is happening. Another thing that we can see from the statistics is that if we look at the areas in the science where we are specializing, and the areas, this is not the KETs societal challenges, but we will have the same picture more or less for the KETs. So where you are specializing in certain areas in science development, in the universities and the PROs, we are not forcefully in line with what they are specializing in industry and in startups and scale-ups. And that could also be a reflection for us to take, and it's linked to the kind of dialogue and communication probably between industry and the public sector and the way we organize our efforts and also our funding efforts. And the third element I wanted to introduce in the reflection is the relationship between markets, so demand, and supply. If you look at here, you can see that for the trade specialization, you can look at trade specialization statistically, both from the export part, but you can also have the import part included, and it will show a little bit similar perspective. So, as a difference between what the firms are investing in terms of R&D and what we're doing in where we are strong in export, where we have strong competitive edge. You see that for the health sector, for instance, we have very strong firms in Europe. It's mainly because we do have strong traditional firms in the pharmaceutical industry, and we also, in a certain sense, many countries are a hub for companies that are not European, but they're operating in Europe. So we are much stronger in the export part than in the technology development part, which is in terms of the future is a worrying sign. The other interesting thing you can see from here is that in the climate, which is clean tech and the revolution towards a more sustainable future, we see that we are not strong in the exports, or as I said, we don't have a competitive edge in the export to the same extent that we were strong. And there you can see both in terms of science development, technology development, and the way of the efforts of firms investing in R&D. And that is one of the reflection we have there, is that there may be a mismatch between the market incentives we have in Europe for certain, like in photovoltaic and others, and other countries in the world developing products like photovoltaics that are cheaper, and they can go in and they can be exported to the European market. So it gives a message of the importance of linking the incentives for the markets with the incentives and the development of technologies that we are doing in the firms. So this was a little bit, so in my conclusions, first of all, KETs has always been important. It's very important for our policy. We have, the EU has a competitive edge in certain of the future fields. So there you can reflect upon, should we focus on where we are strong and collaborate with the US and China in the fields where we're not so strong, where they are strong. We have to keep in mind that 80% today of investment in research and development, both public and private investment, is made outside of the EU. So the EU is a small and shrinking actor in the overall context. So what most people think when they think about specialization is that we have to focus our efforts and make a difference on where we can really scale up and be strong. And in the other areas, perhaps we could be stronger in collaboration, reaching out and working together with partners in the US and in China and other parts. So this is a little bit, and for a last a reflection in terms of the way to work on KETs across Europe. One thought of reflection could be that we could have a common strategy framework for how to deal with the KETs, where different parts, because we do finance development both from Horizon 2020 program and from the Stockholm funds and from national funds and from private investors. So I think with there I will stop and leave the floor. Yeah. Thanks.
Thank you very much, Johan, for that very detailed analysis of Europe's competitive position vis-à-vis the KETs, and I think you've left us with quite a bit of food for thought. Let me once again remind everyone, please do send your questions to the speakers using Slido and hashtag REinEU, and we're in room C. And now we move to have an academic perspective on the topic from Professor Dr. Reinhilde Vöglers, who is a full professor at KU Leuven in Belgium at the Department of Management, Strategy and Innovation, and she's a senior fellow at Bruegel, also a CPR research fellow, a member of the Royal Flemish Academy of Belgium for Sciences and of the Academia Europeana. The floor is yours.
Yes, so unlike most of you who are scientists and engineers working in the field, I'm an economist like Johan, and that means you have to picture me as somewhere in the air in a flying car, trying to understand from above what's going on in the field. And this helicopter view, big picture, has the advantage that it may be seeing much more the dots and trying to connect the dots here, but of course without any technical knowledge of what's going on in the field. So my presentation will be very much in line with Johan's here, and it starts with the basic state of affair is that although on average we do have a lot of highly innovative European companies, and we've seen very nice examples here today, these are unfortunately too much exceptions here. On average, Europe really has consistently failed to exploit the use of those innovative ideas and turn that into innovation-based growth, despite the fact that we have a lot of innovation policy strategies and targets for that. Lots of evidence to illustrate this, but Johan already illustrated this too. One important target that we typically are monitoring is what's our R&D intensity with a 3% target. And there you see, although it's a bit difficult to see for you, that's a disadvantage of having a helicopter view, is that Europe is pretty flat on that. It remains around the 2% here, and you see this is taking place, this relatively stable performance on R&D and failure to catch up compared to some other rising rates, which is China and South Korea, which are really impressively increasing here, and others like the US and Japan, which may not be increasing that much, but at least are at higher levels here. So high expectations for science and innovation to bring us out of the crisis, to bring us at innovation-based growth, but apparently a problem of not being able to reach these targets. And that's basically because a lot of these problems that we are facing in Europe are really structural problems, long-standing problems, having to do with the fact that we actually have a failing capacity for creative destruction. We're missing specialization in those sectors which are at the base of innovation-based growth. Not only failing to specialize in these sectors, but also missing the actors that really drive that innovation-based growth in those sectors, which we call young innovative companies here. So it's missing the sectors and the firms where most of that innovation-based growth is, failing to specialize in these areas here. And that's also partly related to a problem of not having the innovation system in order to deliver that specialization, because we have too much fragmented science, research and innovation. So we're missing these innovation value chains within Europe which can connect the science and the technology and the innovation and the markets that you need in order to be successful in these new innovation-based growth sectors here. And this on top of fiscal consolidation pressures, so which really put a lot of constraints on what governments can actually do in order to alleviate these problems here. So that's in general the diagnosis of why we are not so strong in terms of innovation and not able to catch up, is this deficit in the capacity for creative destruction, failure to specialize in this innovation-based growth sector, and missing the companies that actually do this, drive this creative destruction, which is these young innovative companies here. So innovation-based growth sectors, if you define them as those sectors where most of the dynamics are in terms of innovation and growth. So these are the sectors that also Johan mentioned, like aerospace, biotech, digital. So these are the typical sectors where also the key enabling technologies actually feed into. And if we define these YOLIs, these young companies, so these are really the companies that are very young in age, but nevertheless have been able to move to a status of being a world-leading innovators that drives actually their growth performance. So these are the typical examples like Amazon's, the Googles, the Microsofts, the Qualcomms, Amgens, and maybe you can also add a few European ones here. So first point is that Europe doesn't have enough of its R&D and innovation centered in these innovation-based growth sectors. So we calculate also similar technology advantage indicators. If you're above 1, you specialize in these sectors here, and you see that it's only the US that specializes in these sectors here, and that Europe doesn't specialize its innovation expenditures in these sectors here. And then that holds for all of these, for if you look at biotech, if you look at, but particularly in internet and digital, there Europe is really failing to specialize in these. If you take a look at who are the companies behind, so if you take a look at the largest spenders on R&D that represent the corporate R&D in both in the US and in Europe here, and you take the list, it's from the IPTS scoreboard. So on top you have the ones from the US, the largest R&D spenders there. And if you take a look at who's in that list here, so all the colored ones are the ones that are these young innovative companies that still made it into world-leading positions. You see in the first place, the biggest spender in the US is Microsoft. The fourth biggest spender is Google. In Europe, you see all of the list is all old established companies in sectors like car manufacturing, which are the more medium tech type of sectors here. So it clearly illustrates that what we are missing is these young innovative companies that make it into really substantial world-leading innovators here in these innovation-based growth sectors here. So it's a completely different demography of innovators. And that matters for explaining our overall R&D performance here. So we try to decompose why we have this gap with the US in terms of R&D intensity due to different factors. So 1/3 of it is actually due to the fact that we have fewer of these young innovative companies in our demography here. But what's even more important is actually that half of the gap is actually explained by the fact that the young companies that we have are actually not that R&D intensive, not that dynamic as compared to the US. And actually, interestingly, only 11%, so virtually very small part, is actually due to the fact that our older companies are not performing as well as the US counterparts. So those companies are actually doing as well. It's really the fact that we have less of the small companies, and the small companies we have are less innovation based. And this is basically because we have most of our young companies not in these innovation based sectors. So it's really a combination of not having these young companies and not having the young companies in the sectors that really matter for driving the dynamics. Once we have young innovative companies in the right sectors, they actually are as dynamic and as performing as their US counterparts here. So it's getting the right type of companies in the right type of sectors that would really help to make our innovative system way more dynamic. We zero in a bit on one particular sector, which is the digital sector. ICT, it's a very important sector. It drives a lot of our overall innovation expenditures here. And it's really one that's also characterized as being an innovation-based growth sector here. You have a lot of young companies which really matter in these sectors here. So about 75% of all the scoreboard firms in ICT are actually young companies here. So this is really a very nice illustration of why young companies actually matter. And what you see immediately already is that the US is way stronger in ICT as compared to Europe here. And that already is a first important point to look at here. So overall, Europe is falling behind in this dynamic sector. But if we look at the reason why Europe is falling behind, we really have to look at the whole value chain in ICT. You have different layers here. You have the layer of the hardware, the components. You have the second layer, which is the telecom providers, which offer the connection. And then you have the layer 3, which is the software components, the internet software and IT services here. And actually, I don't have too much time to go into this, but what you can see is actually the dynamics is mostly in the layer 3. That's where really most of the scope is for innovation-based growth. And the layer 2 is the one which is actually the least innovation-based growth, and that's where we have most of our companies, our largest companies, concentrated on. Layer 1 is also one which is moderately innovation-based, but not as dynamic as layer 3. And what you see is that Europe is way more concentrated in layer 2. Asia is the one which is strong in layer 1, and layer 3, where it's really most of the scope for growth, that's the one that's almost virtually dominated by the US here. And it's also in that layer where actually most of these young companies actually are, the examples that you all know here. Of course, this matters because it matters where you are in the digital value chain here. I think it's very well known, this smiley curve here. So increasingly, it's not just on where you are in terms of producing, but who can actually capture most of the value from these digital chains. And that's shifting away from the R&D and the design phase. We had a nice example here before, and to services and marketing, and away from the production type of activities here. And of course, so the layer 3, that's definitely more where most of the scope is not just for value creation, but also for value capture here. One nice illustration of that is the iPad has been very, and the iPod too has been very much examined in that respect. And it's a nice example of, although China, for instance, is doing the manufacturing, the assembly of these components here, it captures very little parts of the value chain here. And the value capture is really by the ones which are responsible for the design and for the R&D, which is in the US, Apple-based. But also still important to identify is manufacturing of components is also a potential area where you can still capture substantial value here. So you have, for instance, also South Korea, in this case Samsung, is also capturing a substantial part by manufacturing really essential components here. And so it's not just only being in the final assembly, but actually that seems to matter less. It's really the extent to which you can bring unique capabilities to the value chain that allows you to capture value wherever that you are in the value chain. So an important question is really not just where you are, but in the chain, so where do you produce, but where does it matter that you produce in terms of being able to capture the value from the chain. And there, as long as you have well-functioning product and technology markets and IPR, it's really the holders of unique capabilities and skills and complementary assets that can really not only add value to the chain, but also based on these unique capabilities have a strong bargaining position in these value chains here and will be able to capture the value as long as we have well-functioning technology markets here. So any firm with unique innovative capabilities, if they operate in these efficient global value chains, and the two examples we heard today were really very nice examples of how you have to fit within these value chains here. And they can be found along all the value chains of the product. So it's not necessarily concentrated in particular parts here. This value capture can take place anywhere within the chain here. And also as a small new company, you can really capture value here. And what really matters is that you have this unique position in the value chain built on innovative capabilities here. So it's a bit small, sorry. But a very important question then is, do you need manufacturing capabilities? Do you need a minimum manufacturing to capture value in global value chains? That's very often a discourse when we're talking about reshoring and offshoring and reindustrialization. So my answer to that would be that it might, as usual economist says, it could be. So it depends actually on how critical that manufacturing capacity is. It's only if it really offers you some unique complementary assets that it really will be important to keep that part of the value chain and to have that value chain part in order to capture value. But if it's not, if it's very routine type of manufacturing that you can easily outsource, it's not the part of the value chain that you need in order to capture value here. So back to the policy agenda. Why is it that we don't have these firms in the right type of sectors here that can actually not only create this new value, but also capture the value from that inefficient value chains? So again, there was a lot of economic analysis on this, trying to understand this. It's basically on the two sides. It's on the one hand because our European companies have lower returns when they invest in innovation capacity, and they also face higher costs or barriers when they need to access the resources for innovation, be that financial or be that skills here. So it's overall a systemic problem that works both on the demand and on the supply side here. So it's very well known what the typical problems are. Also, Johan already mentioned this. So segmented product markets, risk-taking financial markets, problems, less flexible labor markets, product markets, IPR effectiveness. Also very importantly, this insufficient linking in innovation systems, science links, science industry links here, but also the links between the large incumbent firms and the small new entrants here, and also government policy here. So last slide, what we need, we don't know, because to be honest, because it's such a big problem, a systemic problem here, you really need to work on all the different components at the same time here. So definitely what's important is emphasis on framework conditions, but that we have actually been doing already since a long time. I think what we need to focus on more is not just only these framework conditions, but which particular framework conditions and which combinations actually matter most for these innovation-based growth sectors here. So we need a way more sectoral approach to identify what the relevant framework conditions and combinations of framework conditions are to address the specific problems of these young innovative companies in these specific innovation-based growth sectors here. And for that, we actually don't know yet that much how much works or not. So I would advocate for way more experimentation with new policy instruments within that sector-based policy approach, more evaluation and monitoring so that we can learn faster what would be the right policy agenda. Thank you.
Thank you very much, Reinhild, for that very clear presentation, which I think makes it abundantly plain what Europe's problem is and also how we can begin to think about how to tackle it. So thanks to the discipline of the speakers in keeping to their time, we have some time left for questions, and already we have a number that have come in on Slido. Certain of these are for individual speakers, and then there are some that we throw open to the panel in general. So perhaps as I'll take them in the order they came in. So the first question is for Bertrand. Do you expect any radical progress in development of KETs to produce healthy food packaging?
Yes, today there is already this approach, and more we will be careful with this. As a KETs perspective, I will say all this bio approach will be more and more used. Also on the ICT, I'm sure you will have some smart packaging soon, able to control everything, to control the diffusion inside the package. So there is two approaches. One as a producing of the packaging, and after the one to control the packaging. And all this will be an integration of different kind of KETs for the future.
Okay. Thank you. Then we'll move on to the next question for Stefan. Why have you decided to combine the airplane with the car rather than the helicopter in the car?
Yeah, I think why? Because helicopter has physical limitation. Because if you compare efficiency to transfer horsepower to speed, which is a parameter which is very important. If you compare helicopter, need more powerful engines, and after you need more gasoil, a lot of parameters. And aerodynamic of wing has perspective, I think. Now we are able, as I show you this picture from Slovak company, has a world record, reach 300 kilometers only by engine 100 horsepower. That has, I think, perspective combination between airplane and the car, because it's open for parameters which can increase due to.
And then the next question, maybe I could ask you to take that one, Johan. Will new KETs be defined and funded during the second half of Horizon 2020?
Yes, that's a difficult question, but of course we have to reflect upon how to best fund and also to how to best focus our efforts. But this is nothing that we have decided yet. So it's a current reflection. We are ongoing. I cannot say more than that for the moment.
And then there's a question for Reinhilde. What are the socio-economic factors in Europe that inhibit the creation, sustainability and development of EU YALIs?
Oh, I wanted to answer the other question on the KUL, whether it's my university.
Take the two together.
Okay, can I start with the other one then? So yeah, indeed. So we produce these rankings of best innovative EU universities. To our surprise, Leuven came out. We are also a bit self-critical on that, to the extent that, of course, you can always criticize what the indicators were in order to deliver this. But still, indeed, we do have a lot of good examples in Leuven. We have a very well-functioning technology transfer office. We have some very good examples of top scientists who actually turned their ideas into very successful commercial products as well in different areas. What I'd like to say is that this is our performance is actually to a large extent due to skewed few examples which really drive a lot of the returns that we get. We get a few blockbuster cases. That's also, by the way, in the US. Also Stanford, Harvard, all the big universities, their success really drives on a few really blockbuster type of results here. That's the world that we're facing with. It's a very skewed world. It's only very few big successes here. So you have to be a bit lucky to some extent to get these big successes here. But these big successes have to come from the right pool of environment where they can actually come from here. And once you have these successes, they also help to create the next wave here, not only because they generate a lot of funding that then can be used for making sure you get a bigger pool here, but it's also very important in terms of mentoring and by ways of example. So it's basically, to some extent, a lot of luck that we had by adding a few of these examples, which then created a whole ecosystem and atmosphere around this. But of course also with the right infrastructures here. And the most important infrastructure, I think, is giving a lot of incentives and autonomy to the researchers to develop their ideas and also for them to link to industry here. What is still constraining Leuven and why it could actually even do better is to some extent also the environment, the industrial environment here. What we're still missing, certainly also in Belgium, is sufficiently innovative companies that can actually drive and take up some of these ideas. Very often we have to find these outside our local environment here in the US or in Asia. But that's also a policy that Leuven actually is doing, is trying to, and also Flanders, is to make sure that we're sufficiently open, that we capture the demand from industry wherever it is located. And maybe that also answers the first question.
Thank you. Then maybe we take a question addressed generally to the panel for anyone who'd like to respond. Can you describe the innovation chain in Korea as opposed to Europe? Who'd like to start on that?
Just to start up, it's difficult to compare one single country with a whole continent. And one of the difficulties we have in Europe is the fragmentation of our governance, fragmentation of our funding instruments, and fragmentation of our markets. Korea, if I'm not wrong, is about 60 million people. In Europe, we are almost 500 million, with 28 or 27 countries. So it's a different. It's more probably relevant to compare Europe to the US or to China. But that's just to start up the response.
Would anyone else like to comment on that? No. Okay. Then we move. Let's get a microphone.
You always compare Europe with Korea and Japan. Then be specific in the innovation chain, because we are in a state of war basically economically, and if we have to focus more our resources, then we should do this and analyze it more than just saying we cannot compare. I'm sorry.
So I wondered if I could answer the question on Korea. I'm Terry Wilkins. I used to chair the NMP advisory group in Framework 7. And in Framework 7, we invited the head of the Korean nanotechnology program to speak to us. We wanted to know why they were so good at these certain things. It nearly caused a diplomatic incident because he decided to attack his own government. But anyway, the reason is as follows. After the Second World War, they had almost no physicists and material scientists in the country. There were only about 5, I think he said, and they decided they got to invest in certain things. So it's really, and they did, they invested in those things that took us forward into electronics, automobile, and communication. So it was strategic investment by the government, and of course we've got the chaebols, the huge conglomerates that have all the power, and they drive those areas with ruthlessness, focus and ruthlessness.
Yeah. Perhaps, can I also? So I think we always have to be careful indeed by picking few examples that we want to compare ourselves with. Korea and Japan may have some advantages in some areas, but are not necessarily a good example even in the future. So that's why for instance, China is way more important because it's also very dynamic and way bigger here. So it really depends. We have to be really very careful about picking frontiers as targets, different countries. Also but I think a very important lesson we can also learn from Korea is indeed that we need to be sufficiently open when we are developing our innovation systems. Although Europe has a critical scale, I think it's still very important also for Europe to look beyond its own borders here and to try to develop global value chains and global connections here with companies wherever they are in the world, wherever they can have the most power for creating. I'm a bit so that's also a bit of an answer to the gloomy picture from the helicopter. I think what we really need to do is not to be too inward-looking here and really try to look for where the sources are of growth and dynamism, wherever they are. If they are in Europe, fine. If not, we should also be sufficiently open. And I think that's definitely also a lesson we can learn from small open economies here, but that we should also take at the European level.
While we have the microphone in the room, is there anyone else who would like to come in on this point or to raise anything else? Okay, then we go back to Saido, and a question, I think maybe you could address it, Johan. Will KETs be funded at all in FP9?
What an easy response question, no? Well, we're not yet there. I think the response is that FP9 is still some years to go, and the most important thing is to now make a good analysis of where we are now in terms of competitiveness, in terms of sector dynamics, and also in terms of how the different actors are interrelating with each other and where we put the focus. So that's I think one part. We have to make a strong analysis now because we're in a learning period. We have invested, we are investing a lot of money, historically a large amount of money, both in Horizon 2020 and in structural funds through the smart specialization strategies. So we are really in a historical period. So before we go ahead to look into the future, what will happen in 2020 and onwards, we really have to learn now. So this period in the coming year, 2017, we will have a debate in European policy and European Parliament and with member states and with all the actors on the interim evaluation of FP, the current Horizon 2020. And we will also reflect upon the synergies between that and structural funds. So based on that, I think that the next step is to go further but having said that, we have elaborated certain avenues that we think are important. And one of the avenues that links up to what Ranhilde was mentioning on the difficulty we have with fast-growing enterprises and to support and scale up of startups that we have seen today, is that we need to work more on the funding instruments and how we scale up better innovative enterprises that are based on both tangible and intangible assets. So that we are working on under the label of European Innovation Council. And that will probably grow as well in the future. But we are working on many different strands at the same time, and it's a little bit too early for the moment to talk about FP9. That would be the response, I think. Yeah.
Thank you, Johan. So we have 2 minutes left and 2 questions here, so maybe we can deal with them quickly. Taking the last one first, the IPCEI has been promoted strongly. Is it going to solve some of the systemic problems?
I don't know the details of this IPCI story, but my only advice is keep it simple and keep it simple for everybody, SMEs and so on. It's nice to develop tools like this, but it must be simple.
Does anyone from the floor want to come in on that? No. Okay, then we'll finish, I think, with an appropriate question, and it's for Stefan. What is the maximum speed in car mode?
It's probably his new customer. I think we reached his limitation of 130 kilometers per hour. That we reached this speed, and in modes, the plane during landing and during takeoff, I reached a much higher speed. It is very stable because it's very light, and in future we want to use this variable aerodynamic that we can change forces and reaction on wheel that can be very stable. Speed for takeoff is approximately 120 kilometers was on this prototype, but we expect with new forward flaps go something decrease. Because for pilot, without experiences is much better if speed for takeoff is approximately 90 kilometers per hour or 80 kilometers. That is our target, go to lower with speed.
Well, hopefully that is enough to convince your potential customer in the audience. And on that high-flying note, I think maybe we'll bring this session to an end. I would like to thank the speakers very much for their contributions, and also thank you to the audience for the many interesting questions we got through Slido and for the contributions from the floor. Thank you very much.